if you touch this tab, you can be able to access the what the parameter is coming in the left side of your display. This is called the control display. This control display, the system is looking as small, but this display is little the same complexity they have, same like the previous we discussed about the software. But if you maybe get familiar after using the system long time. Okay, here there is the one diagram how the system is this, how they are controlling the process. Here we are using the base jar, and the next we are using the sensor. Sensor means we are using the QCM, and the QCM is the next to the QCM we are using our deposition material, and both the QCM we are going to monitor in our system, and the power we are going to control by help of this controller. In the top side there is a sputtering line, a sputtering control, a sputtering shutter. The three parameters we are going to control by help of this automatic evaporation controller. One parameter is this sensor, second is the power, and third this is the pneumatic shutter control on the top of your materials. Okay, now we have to discuss about the display control, what the option we are going to see inside. In the display there are the three parts. We are dividing this display in the three parts. One is called the menu 1, menu 2 and menu 3. If you are pressing this next menu, then you are able to access all three menu of your display. But at a time you can only able to see the only one menu. You cannot see the three menu together. If you are discussing about the first menu, this is the first menu. In the first menu, like they have the quick edit option, auto, manual, 0. In the first line, we can quickly edit your process. By suppose in the quick edit they have all possible options which you are using for the control our process, like PID controllers, powers, thickness control, deposition controls. And next, if you are discussing about the next menu, they have the next graph display. If you are pressing this next graph display, then they will show in the graph. There are 2-3 ways to monitor the graph. Like one is the rate of deposition with respect to time, one is the deflection with respect to time. We can change and we can see. And the third menu, we can edit our process, we can edit our field. How much PID proportional integral deviation value you want to put, and what you are expecting for the depositions rate. We can edit this value. Next, about the deposition. Generally, the people are doing this kind of process. Means first they are doing the ramping. They are divide. Generally, you can divide your process into 3-4 parts. But it's become the more complexity to create your recipe, because it will take the time to make the power adjustment, make the rate of depositions, and this is the graph generally ideal people are doing. But it's in the industry they are doing, because it take time taking process, and the little challenge to configure the power rating.
So do you have to supply the Z factors to all materials? They have paid for them?
For the all material, you can able to see inside the controller. They give the 100 materials density and the jet factor, because jet factor is an important parameter. We have to always select. But in case you are using the beyond of this list, then you have to calculate the density by help of other material and the jet factor, and you may change this value. But generally it's coming for the 100 materials.
Yeah, so if it's not there, you calculate this, you have to calculate Z factor?
Z factor, yesterday I saw there the one formula like the density divided by there the one formula.
Okay.
And also I saw there the many equipment is available. They are calculating the density as well as the Z factor. Yeah. Now we are on the stage to discuss about what is the DCS sputtering. Because here in the system we are going to use the DCS sputtering. For the doing the DCS sputtering, we have to understand about what is the background principle for this DCS sputtering. In the DCS sputtering, we are going to apply the power in between your target and your in between your target and the substrate during inside the low vacuum conditions, and we are applying the argon gas. When the argon gas will be present under the low vacuum condition, it will be ionized due to the low vacuum conditions. And when applying the higher voltage in the substrate and target, then this electron density on the positive plate and negative plate, it will be increased. After that, after some time, due to the high energy, the electrons start moving from down to top, and they will react with the argon gas, and they will be color will be changed. This process it will continuously run, and during the material which we are using on the top of the DCS sputter, it will be travel along with the electron which coming from the argon, and they are going to fix on your substrate during the process. And this process is also called the plasma stage. When during the process we are able to see the color, it will be changed inside the bale jar. Then this process is called the plasma stage. Okay, here is just I'm explaining what is the recipe, how we can doing this one. Just I mentioned here, maybe it will be changed, but there is one common process everywhere. First process we need everywhere to make the low vacuum. This is the important parameter. But going to the low vacuum, first we have to do like we have to take the bale jar up, we have to fix our substrate. Second, we have to put out the DCS sputtering source inside. We have to connect the argon gas. When we reach to the low vacuum condition, 10 to the power minus 5 torque, that time we have to apply the 50% of the flow rates. Then when the pressure get stabilized in the millitorr, in the range of the 5 millitorr, then we have to give the power. Near about we are using the power. We are using the power in between the 0 to 50% power to do this process. This is the basic steps which always we need to do in all kind of process. Okay. How we can decide the thickness? Because in the DCS sputtering, they have the working limitations. Because yesterday I spoke with the manufacturer what is the limitations, because we cannot apply the continuously voltage in the substrate and your sputtering source, because due to the external supply of the voltage, your DCS sputter become the more hot. Then if you are use this sputter source more than the 10 minutes, then after that it will be chance to get the damage your sputter source. Then the maximum timeline to use your DCS sputtering is the 10 minutes. And this is the thickness generally we are calculating. If the current, if you are able to see the current is the 50 milliamperes, then we are expecting, this is the 62 angstrom per second we are depositing the material on your substrates. This is the standard rates. What is the limitations of this DCS sputtering? The limitation is that we can operate this one by the 10 minute maximum. This DCS sputtering. Next limitations, we are expecting if you are using this DCS sputtering, then you can grow the thickness of the 477 angstroms, and if you are using the system maximum 10 minutes, then you can go 1000 angstroms approximately. This is about the DC sputtering process.
But you can cool it down and start again to...
You can do it, yes.
We can use both processes together. Means
No, both
evaporation.
processes you cannot do together. No. Yes, this is the one important parameter that is escape will form. Like if you are doing the evaporation system, that time you have to take it out with DC sputtering from inside the chamber, because inside the chamber, when the material will transfer,
to contaminate the
it will
source.
become to DC sputtering also. And DC sputtering, because the material have the high temperature, they will burn you over the DC sputtering line, DC sputtering connections. Okay, what is the maintenance we need to do always, especially for this thermal evaporation system?
So just a minute, for the sputtering source, the source of sputtering, at what position, at what angle is it to the substrate?
Okay. This is your substrate, and we have to maintain the 10 centimeter distance. This is recommended distance. And downside, the one sputtering source, I'll show you the image. The back side, I kept some the one slide. I'll show you how it will look like that. Okay. This is your DC sputtering source. This is the DC sputtering source. Okay. Then we have to maintain the 10 centimeter distance, and we can go for the process. Last time I remember I used the aluminum foil. Then we not got the good thin film on your substrate. The reason behind it, because this aluminum, if you are using for the food industry, then they are adding the carbon there. Then if your material is not pure, then we cannot get the pure coating there. Then suppose if you want to do the proper coating, then first you have to bring the original material, pure material, 100% maximum accuracy. Otherwise, like the coating, like impure coating, it will become.
But will it be at angle 45 or?
No. We have the angle is that we have to maintain. You may say like 180 degrees, like a straight test maintain. Yeah, so that they can directly move this argon gas, like they can apply. This is we are going to apply the voltage. Then due to the current density, and they will move. Okay, that's very important point is called the maintenance schedule. Suppose if you are not working, then also it is recommended to use this schedule. It will be good for instruments. So what schedule you have to maintain? Suppose if you are doing the process, evaporations, then there are some chances that the material will come to the contact of the bale jar. On the interval of the weekly, on the interval of the week, 1 week at 2 weeks, please use the soft cotton material, and by help of the acetone isopropanol alcohol, you can clean your bale jar, you can clean your substrate holder. The weekly, the monthly is recommended to you. The second point we need to do this sputter source on the interval of the monthly, when you are going through the process. Suppose you are doing the process and you are not getting the plasma stage inside the vacuum chamber, that time use the scotch bright, make the gently scratch on the surface of your DC sputtering, and you can use the third important point here just is missing from here. In the interval of the 10 days, 15 days, just you are not using the system, just turn it on after checking the facility so that they can create the low vacuum. Because if you are going to start the process, it will not take the more time for you. And on the interval of the 1 year, also need to check the oil of the vacuum pump. But I have to check the specification, which kind of oil you are using. I have to check this point and I will keep you updated.
Do you recommend to heat it, to bake it out from vacuum to make it fast at the beginning at least first time? Because if the vacuum is not reaching 5, 5, then you may need to put a light bulb which feeds up, so while you're pumping, to evaporate all the...
No, first time I remember when I came here, it's first time, yes, it took me about 5 hours. And even in the manuals, you may surprise, it's mentioned that if you are running if your gauge is open for the couple of days, then it will take throughout the whole line to create the vacuum.
That's what I'm saying, if there's a lot of moisture inside,
Yeah,
this thing to put some temperature, some heat inside while you're pumping. It will expedite the process.
You may do, but to be honest, I went by this manual process. That is all about the equipment. If you have any doubts, you may write me an email. I'll share my card detail. I'll able to respond within 24 hours. Because I try to cover the maximum points inside my presentation. But in case if anything missing in our presentation, you may write me.
Will you need the presentation?
Sure. I have the soft copy. And the one more important parameter point in the manuals everywhere, they're mentioning that read the manuals because it's little, when you're going for the auto process, little complex process to make the recipe. That is always recommend to read the manuals to use the systems. Like it's not too straight and forward because we are just hitting our substrate, the only one concept. But behind this one there are 2-3 parameters we need to always identify during our process.
But for cleaning, I think whenever you use different material should be cleaned.
Yeah, that will, if you are doing that can be excellent. But this is the minimum schedule. Like you may go for this one, but if you are doing that can be excellent.
Usually you clean after each evaporation.
If you are doing that can be excellent.
Pregnancy after that.
That's the jar recover.
Through the gas of pregnancy, so we need to buy zinc keto or